Hey, just a sound test. Can everybody hear me fine? Let me know in the chat if everything's okay. Make myself a little bigger here. There we are. Nice. Welcome to the stream, everybody. I know it's been so long. It's been, what, a couple months now? So that's okay, because I wanted to make sure that we do the stream right. So welcome back to everybody who was on the previous season. We're on season 3 of Engineer Man live streams, and we're kicking it off with a stream on Git. So I want to go through a couple channel updates and announcements, and then after that we will get right into it. We have a slightly different format, which I'll talk about in a second. In the meantime, while I'm doing the channel update announcement type stuff, if you have any questions about Git or otherwise, go ahead and put them in the chat. Make sure you use one of the prefixes. You can put Q colon, question, or question colon, and then your question, and then it will push to me on Discord. That way I don't lose it. There's always a lot of chat, so I don't want to miss anything. So if you have a question, use one of those formats, and you'll be okay. The first update is on 300K. We're about 1,800 subscribers away from 300K. I have the 300K video. It's done. It's uploaded. It's ready to rock. It's not a meme. I know I missed the 100K video. I missed the 150, 250, all that. Well, we actually did a 250K video, but it wasn't. I didn't like the way it came out. I had a good idea in my head, but when we finally got moving on it and did the recording, it wasn't good. So, and as you know, I don't release anything that's not quality on this channel. So the only sensible option for that was to simply scrap it and start over. So after we scrapped the 250K video, we started working on the 300K video, and we did actually finish it. It's really great. It's a completely unique thing, like nothing you've ever seen on this channel, and I think you'll really like it. So in 1,800 more subscribers, I will release that to everybody, and you'll get to check it out. For the so the new stream format, the way we're going to do streams going forward is the thing about the streams that I always like a lot is the question and answer, and not just the question and answer about unrelated topics like my background or what do I have hair? Things like that. I always enjoy the question and answer portions for on-topic type stuff. So the way we're going to change streams going forward is about a week in advance of the stream. I'm going to put out a Google Forms thing for people to fill out, and then the topic we'll be doing it on. So in this case, we did Git. About a week ago, I put out a form and I said, hey, give me all your questions up front, and let's just do all Q&A. And within those Q&As, I can expand on certain topics, or I can do demonstrations or things like that. That's better than me just coming up with an hour worth of stream stuff that maybe people don't even need. So everything we're doing in this video today is the result of people's questions, and some of them are duplicates, which means that that particular thing about Git is probably pretty important. So we'll definitely be going over that. So I think that's going to be the format going forward, and it's great. I think I got like 26 responses. Of course, I was able to condense some of them because some of them were duplicates. Like for instance, today we're going to be talking about rebasing, and a lot of the questions were related to rebasing. So I basically put those together. I'm not going to answer 5 rebase questions. I'll just talk about rebase, in general, and then that'll cover all 5 of those. So that's the new stream format. We'll see if it works. I think it'll be good. As far as frequency of streams, I think it's just going to be whenever there's a good topic to do a stream on. I don't think it's going to be hard set every 2 weeks. Maybe it's once a week. Maybe it's once every 3 weeks. I don't really know. I'm not going to set to a particular schedule. I'm just going to do them when a good topic comes up. And then finally, for future videos, we're finishing up database stuff. We got about 2 more videos related to databases and MySQL. We'll wrap that up, and then we're hitting Linux hard. We're doing lots of Linux content, and we're going to continue, getting people going on Linux. Whether you're a new Linux user or a veteran Linux user, we'll make some good content for everybody. So let's do a brief, just general Q&A. I have lots of questions. In fact, I'll excuse me, I'll switch to those now. I have a whole thing of questions here. And this is all the questions that came from you. I didn't come up with any of these. So these are all, oh, I gotta make myself smaller. Oops, that's not the right one. Make me a bit smaller. Oh, I didn't mean to move it. There we go, better. Did not mean to move myself like that. Yeah, so I have a whole mess of questions, and every single one of these were sent in from one of you through that Google form over the last week, and then I've condensed them all. So we'll get moving on that. Let's do a brief Q&A on things that have came. Oh, there's so many. Oh my. Okay. I want to make sure that I answer all the ones from the forums for sure, and then I'll try to answer some of these other ones as well. So, GB Professor Wally, you asked about, are you a Git Flow fan, GitHub Flow fan, modified version of these, or something else? And the answer to that is I generally follow what's called Git Flow. And since you mentioned that term, I'll assume you know what it is. But for people that don't, Git Flow is kind of this idea that if I were to summarize it in just a few sentences, Git Flow is a workflow whereby you have a master branch that really nobody touches. You have a development branch, which is non-release ready stuff that came from sets of feature branches. So the workflow might be a developer receives a new task to build a new feature. He'll create a new feature branch. He'll do his work on that feature branch. He will then get it reviewed. He'll then merge it into development branch. And then from development branch, somebody, maybe a senior team member, will check out the diff between development and master branch and then merge the changes from development into master. And then it's the master branch that actually gets released, whether it's an Android app, iOS app, or web project, or open source release, or whatever. It will be based on that final master branch. So in Git Flow, the master branch is thought to be work that is 100% done, tested, and release ready. Development branch is kind of like integration branch, because development branch is going to contain many different features from possibly many different developers, and that's going to be the place where you can do testing ahead of time before you integrate that into the master branch. Emacs, I'm going to skip that one. So I have slight internet problems here. Okay, I think it's fine now. It seems like it should be easy, but how do you create a local repository and then add it to your private GitHub repository? So that's generally not the way it would work. Usually what you would do is you would create a repository and then you would clone that repository and you'd have a copy of it. So for those that are maybe new to Git, I should have probably led with this. For those who are maybe new to Git, Git is a way of tracking changes over time to a set of files. And it does so in what's called a distributed manner. Git is considered a distributed version control system. And this is similar to a couple other version control systems that are also distributed. But the core feature of a distributed system is that everybody that has a repo has a full-fledged copy of everything. And that includes, so if you have a copy on GitHub, that's a full copy. If you make a clone, that's a full copy. If you deploy it to a server, that's also a full copy. So everywhere the repo exists is a full copy of that repository. And what you get with this is some of the older version control systems, things like SVN, were a central repository where you need to check out individual things that you wanted to work on. And of course, that's not ideal because that limits who can work on what. But that's how it controls it. It makes it so, there's never any issues. With a distributed system, everybody has a full copy of the repository, and then they do their work, and then they commit to usually a central repository. Maybe it's on GitHub or Bitbucket or just some private server. And then all the merging happens when people pull down the changes of other developers. The distributed system has crazy benefits over something like SVN. So that's what Git is in a nutshell. And you could store changes to your code as often as you want. And then you have the ability to go back and make your code or make your project, not just your code, just anything in the project. You can make it look like it was at any point in history. And when you add new changes to a repo, we call that committing. So if a repo has 20,000 commits, you have the opportunity to roll it back to any one of 20,000 states at any point in time. So it's a very powerful thing to have. And if you're not using Git today, you definitely want to go check it out, even if you're a solo developer. One misconception is that Git is just for teams. That's not true at all. You know, Git has huge benefits for solo developers as well. Best workflow to resolve conflicts. We will talk, actually I can talk about that briefly. So a conflict in Git is when two people work on the same code, they both make commits, whoever pulls later has to merge the code from the other person into their own code. And if your copy of the file changes something that their copy of the file changed, then you'll have what's called a conflict, whereby the system sees that, oh, we have changes that are in the same spot in a file, what do we do? So, but it's also, if it's not in the same spot, it could be at the top of the file and the bottom of the file. Git will attempt to merge this automatically, and Git's very smart. And if you have changes, if your changes are at the top of the file and the other developer's changes at the bottom of the file, Git is going to be able to look at that and say, okay, well, I'll make a third file which contains both developer A's changes and developer B's changes. No problem. And it's done. It's merged. The conflict happens when both developers change the same file. If you change the same file, then you have a conflict, and Git's not going to be able to know what to do with that, because how's Git going to know which it should actually be? So if you have a conflict, the system will ask you to manually merge it, and to manually merge it will require you to open the file, and then Git will show you basically the area that is from developer A and then the area that's from developer B, and then you'll have to choose which one you want to use. And you can do this manually. There's also tools out there that are made specifically for resolving, you know, Git merge conflicts. But the general workflow is simply resolve the conflict. That's really all you can do. There's a couple strategies you can use to reduce the possibility of conflicts, one of which is rebasing. You could rebase your feature branch off the target branch that you want to merge into prior to merging. Sometimes that helps, sometimes it doesn't, but that's one way. But the best way to avoid conflicts is to make sure that you're developing your features on a branch that you've freshly pulled on, and making sure that if your feature branch lasts a very long time, that you are constantly integrating stuff from the base branch back into your feature branch. Okay, there's so many questions. I gotta speed up here. Can you please show how to resolve merge conflict the old-fashioned plain text way? Yeah, so that's actually what I just described. Basically, Git will just mark, you know, where the conflict is, and then you pick the one that you want. Git. Okay, that's not related. Would you be executing Git commands live? Yeah, we're gonna do some Git commands. How does set upstream work? Basically, set upstream says this local branch should track the branch from the origin. So if you clone a repo from wherever, and then you make a feature branch, call it like new feature, and then you do some work on that feature branch, when you go to push that branch, it's going to say your branch isn't tracking anything. So what you could say is set upstream, and then you pick the branch it should track, and then it will push to that branch. And then from that point forward, you can push and pull from that branch. You generally only have to do this once, and it's when you create a new branch that you haven't yet pushed to the remote. And you can do that with -- set upstream, or you can just do -u, whichever one's fine. Example of when you use rebase, we'll talk about that over the course of these questions. Again, I'll just get back to that. How to fix unrelated histories. Yeah, we're gonna get to that. That's one of the questions in here. You once said you're running a GitLab on your own server. Are you still running it? Absolutely. I run my own GitLab server just because sometimes I have very large projects that don't fit on GitHub, and also, at least in the past, GitHub for private repositories used to be paid, and I didn't want to pay for it. And then on Bitbucket, I don't like Bitbucket. I prefer GitHub. So I was kind of in this pickle where, I can either have the software that I want, but I gotta pay for it, or I can have the software I don't want, but it's free. And then GitLab suddenly came out of nowhere, or rather I discovered GitLab and decided that this is basically everything I need. I can host this on, at my house, on my server, and everything will be fine. So yes, I absolutely run my own GitLab server. It's easier than you think because GitLab for your own deployment come with basically a single Docker command. You can start your GitLab instance with Docker. And that's what I do. It's extremely easy and it's not a ton of maintenance. Okay, I think that's good for now. Let's move into the actual questions that came in through Google Forms. And then we're actually gonna do some examples here. I'll actually show you how to do certain things. So the first question here comes from G. Professor Wally. Thank you very much for the $4.99. I appreciate that. And here are your questions. He asked, what's an easy way to undo a previous commit? Add a few more things and then recommit so as to keep commit history cleaner. So the best way to do this, and this is assuming that you haven't pushed your commits, although even if you have, this method will still work. You just have to do what's called a force push because this will change the history. But if you were to create some stuff, so you add a new file, like right now, my history is clean. So what I'll do is I'll just add my name to a file called name.txt. Then you can see that I have, one file change. I go to commit that, git commit, add my name to name.txt, and I commit that. And I think, oh no, that's not what I wanted. I wanted to put my name and then I want to put a number 2. What do I do? I've added a commit here. What we can do is we can actually just undo that commit and put all the changes back in my current directory. So if I do git status, you can see that I have a clean working directory at the moment. If I want to just undo this commit, add my name to name.txt, all I got to do is git reset -- soft. The soft part's very important. Head, and I can add 1 caret saying go back 1 commit. And then when I do that, if I run git log again, you can see that I just have if I run git log again, you can see I just have the initial commit. And then if I do git status, you can see that the file that I just committed has been uncommitted, and now I can make my changes. So I could, open name.txt, I can add a 2, and then I can recommit. Git commit, added name and 2 to name.txt. And now I'm good to go. I'm able to fix it. I know this wasn't part of your question, but if you wanted to just change the git message, like maybe you made a spelling error, you said added nam, instead of name, then all you got to do for that is just git commit -- amend, and then it will open this back up. You can fix whatever you want to fix, name.txt, again, change the message, and then save. So it's important to note that this does change history. If you haven't pushed this commit to a repo, you're good to go. You're fine. You can now just do git push and you'll be okay. If you did push it to a repo, what you can do is you can do a force push, but you got to make sure, force pushing is not evil as long as you do it correctly. If it's your own repo, force pushing is fine, because what force pushing will do is overwrite a commit with another commit, or a set of commits rather. When you force push a repo to another repo, you're essentially saying, take what my repo looks like and make it what the remote repo looks like. And of course, ordinarily that would be bad, because anybody that has commits in the public repo that you don't have, you're basically going to be discarding by force pushing. But if this is a feature branch or it's your own repo, then it's perfectly fine. And this is a perfectly valid way to do this. Yeah, so Sasha said, hard will make changes to your working directory. If you didn't specify hard, like if I, or I'm sorry, if you didn't specify soft, what you would actually do is you would actually just discard the commit altogether and your work would be gone. So that would not be ideal. Unless, of course, you had already pushed your work to some remote repo, in which case you could just do a git pull and then you get that work back. But if you did a ton of work and then you committed and then you did a git reset hard head single caret, you'd completely lose your work. So next question is the Git flow. I already answered that. I'm a Git flow fan in general. For most projects that I've done, Git flow seems to be the thing that makes the most sense. Sometimes if it's a smaller project, I will just leave out the development branch entirely and just go from feature to master. But that just depends on the project and who I'm working. Like if I'm working on it with another person, we're not going to bother with, master, develop, and all the feature branches. We're just going to go straight from feature to master. So you got to look at just, what your situation is, what makes sense. I know the more people that work on it, the more you want an opportunity to do integration testing between a feature branch and then a development branch, and then finally some additional testing between a development branch and a master branch. And then possibly you even want to do staging testing once it's in master just before you actually deploy it. But here again, people have their own workflows. There's about 1 billion of them out there. Yeah, not that they're all standardized, but it seems like everywhere I go, people are doing some variation of Git flow. But that's just been my experience so far. Do you recommend source tree? I'm not sure what that is actually. What is source tree? Could you explain the concept of cherry pick? The idea of cherry picking is just to take a single commit and apply it elsewhere. And it's good if you have a commit at some place that represents a certain amount of work that you've done and you know that that's all you need. And if that's the case, then you can just kind of cherry pick that commit and put it somewhere else. So that's essentially the whole purpose there. So this question was asked by Pizza. It was how to correct unrelated Git histories. And this is kind of a tricky one because while Git does let you rewrite the entire history of the project, it does have some consequences or implications of doing so. So if you want to rewrite the history on a private branch, you would simply rebase that branch, probably an interactive rebase, and then you'd simply fix the problem and then force push. It's no big deal, because it's a private branch and it doesn't really matter. On public branches, this is a little more challenging because on public branches, you have to be mindful that you're not the only one that has that code and you're not the only one who's doing updates to that code. So if you're not mindful of this, you'll end up pushing a rewritten history and then people have to pull that rewritten history. Now what that's going to cause is Git is going to say, oh no, I have modified history. My whole history is gone. I'm going to try to do this massive merge automatically. Possibly it's going to fail. And then you're going to have some big problems. So you got to be mindful on public branches about, doing big history changes. Generally speaking, unless there's some serious major need to rewrite some history, I would just advise not doing it. Any possible problems with commit messages or commits or lumping in commits or anything like that, those really should all be resolved at the time. Those should really all be resolved at the time you push your feature branch and then ultimately merge your feature branch back into develop. You should resolve it at that time. Our next question is, this was asked by SuperChump123. How often should changes be committed? And with that, how many changes should be contained within a commit? So in my mind, the frequency of commits is less important than the messages. To have a good Git history, the idea is to have, if you can, it's not always practical, to have one commit that represents one useful thing. So if you add a useful file that changes something, you would want to commit that. If you add a new feature, you'd want to commit that. But here again, you know, some work is large and drawn out, so you'd want to break that stuff down. Me personally, I like to commit when I've accomplished something useful or worth committing, you know, and that just depends on what the project is. If I write some code that I know is done and it works and it's stable and I don't want to lose it, then it makes sense at that time to make a commit. But I'll also commit when I want my progress to simply be stored. You know, like if I'm working on a project and then I know I need to go on another project, then even if my work's not done, I'm still going to commit that work. I'm just going to commit it to a feature branch. That way it's not part of the main project. However, it is securely stored in the central repository where people can look at it if they want, and I can always recover it later, especially if something were to happen to my computer or something like that, then that work would be stored already in the central repository. So you want to do that. I mean, it's fine to commit work that's not done. That happens all the time. It's not like you go 4 days without making a commit just because you didn't actually finish what you're working on. And the reason that you can commit as often as you feel it's necessary is because at the end, you can always squash all of those commits down into one commit that will have a message that is specific to what those sets of commits do. So this is one of the big, you know, thing that Git is really good at is having a nice clean history. There's other version control systems that are very anti-history changing, you know, and making that all better. So, but Git is not. Git's all about changing history. It's fine. You just got to know. You got to know the implications of what you're doing. Okay, next question is by unknown. I don't know who submitted this. So when I put the Google Forms out there, you don't have to put your name on there. It's only if you want me to mention you in stream. You can just leave that out entirely. So this person is unknown. I pull code and work on several of the files. I realized that one of the files just needs a do-over. What is the best way to get a clean copy of that single file? So the best and only way to accomplish this with Git is git checkout and or git reset. And the reason I say and or is because sometimes you got to use both. Other times you can just do git checkout. So for an example, right now I have my name.txt. I can do git diff. I can see the difference. I've added 2. No big deal. So if I do git add and I add that file, it's now in my index. Once it's in the index, you can't revert that file back to its original state directly with git checkout. What you have to do is you have to first git reset. And what git reset will do is it will move that file out of your index back into your sorry, I'm saying that wrong. It's going to move it out of your index back to your working tree. So if I git reset head name.txt and I do git status again, you can see now it's changes not staged for commit, because there's always changes to be committed and then changes not staged for commit. So once I have it here, if I want to, and we can look at the contents of that file, it says Brian 2. If I want to revert that file back to when I originally found it, I can simply do git checkout name.txt. And you can see now if I check what it is, it's just Brian. And if I do git status, you can see that my directory is clean. So keep in mind that git checkout will get rid of, it will get rid of whatever you were working on in that file. And keep in mind that you can also git checkout entire folders. So if you have a folder that you want to revert back to the way you found it, you can git checkout that entire folder. So that's the best way to do it. If it's changes not staged for commit, you simply have to git checkout. If it's changes to be committed, you have to reset and then git checkout. And that's how you would do that. Next question, also from unknown. Is there an easy way to git diff and see changes side by side easily? The short answer is to do it directly through Git. The answer is no. However, there are external programs that do exist, things like Meld or Vim. You know, if you want to do it without a GUI, you know, those will both take the 2 files, put them side by side, and then show you kind of what is different between the 2, and then you can decide what you want to do. In fact, I think Git, I don't know if Git actually contains a Git made diffing program or if it just uses an external program. I think it actually uses an external one. Colin Paget, thank you for the 5. You should be a college professor. You're always crystal clear and to the point with no BS. You need more subs. Thank you. I really appreciate that. I would love to be a professor. It's just I don't have that level of education, so it's not something I could do. But I think that's probably a job I'd really enjoy. I used to be a teacher, not for anything tech related or anything in academia, but I've always really enjoyed it. I feel like I can communicate things, clearly and correctly. So I appreciate those kind words. And yeah, I need more subs, but it's okay if I don't. That's fine as long as I'm people find the channel and they get help. It's not a big deal. Like the sub count's not super important to me. What's important to me is putting out high quality content that teaches people things that they're interested in. So, but again, thank you for the 5. I appreciate that. If you're not already a supporter on Discord, just message one of my team members and you'll get that role. Thanks a lot. Finally, the big question, and this was unknown, Demo, Jameson, and I think another person asked, rebase or merge? Is there a simple rule to follow? So I think that question came from an unknown person, but the other two people asked about rebasing and merging. And the simple answer is that one doesn't necessarily replace the other. You can't just rebase or in this context, what the author is asking about specifically is that if I have a feature branch and I have a development branch or a master branch, something like that, should I rebase or should I merge? And the real question is, should you merge or should you rebase and then merge? And so let's talk about exactly what that means. So if I have my project here, let me get a clean directory here. So right now I have a master branch. If I have a feature I want to do, I can create a new branch, git checkout -b new feature, or rather just feature. What this will do is this will create me a new branch and check out that branch to let me do some work. So if I echo, a 1 to number.text, that'll add that number in there. I'll have a new file. I can add that file. It's no problem. Git commit, add new file, good to go. I now have, clear. I now have name and number and all that. So right now I have a feature branch and I have a branch I have to merge into. And the question now becomes, what do I do with it? I could just merge it in, and sometimes that's fine. If I were to check out my master branch and do git merge feature, it would work perfectly. It would just take my commits and it would apply it to master, and that would be the end of that. And it would do so in what's called a fast forward manner. And a fast forward is when master branch and feature branch all have the same old commits and just feature branch has new commits. So like if master branch has commits A, B, C, and D, and feature branch has A, B, C, D, and E is the new file I just added, then when I merge it in, it's just going to fast forward master to feature, and then that's the end of that. But if master branch had commits on it as well, maybe master branch has commit F and feature branch has commit E, then when I go to merge feature into master, it's going to have to reconcile commits E and F and determine how it should merge it in. So here's where rebase comes in. What rebase does is it takes one branch and makes it the new base for your current branch. So if master branch has A, B, C, and E, and feature branch has A, B, C, and D, then what you can actually do is you can rebase, and what it'll do is it'll pull the commit from master and apply it on feature branch, and then apply the commits you made to feature branch on top of that. And what this does for you is it makes it so it's kind of the equivalent of if you just saved all your work and then rechecked out the branch and then reapplied your work. And in doing that way, you no longer have any merge problems because you now have all the new stuff from feature branch. The good thing about rebasing is that when you rebase in this way, you're guaranteed not to have a merge conflict when you merge it back into master. And that's because you will have already resolved it by rebasing. And the process for rebasing essentially is when I rebase master onto feature, what it will do is it will remove all the commits from feature. They call it unwinding. It'll unwind all the commits from feature and pull them off. It will then fast forward feature to where master is, and then one by one it'll start applying the commits from feature back onto the feature branch. And it'll just do so until it comes up with a conflict. And sometimes there's no conflict, and that's always the best case scenario. With Git, you don't want to have conflicts. You want to avoid conflicts as much as you can. But what it will do is it'll apply commit 1, then commit 2, commit 3. If it applies commit 4 and it finds a conflict, then you will need to resolve that. And you don't do so with another commit. Remember, this is a rebase. So you just add the new files that are fixed, and then just git rebase continue, and then it'll just keep going. So the answer to the question is, I like to rebase if I think I'm going to have a nasty merge. And I also like to rebase if I know that there's work in master branch that I need to have on my feature branch to make my stuff work. So I'm constantly rebasing onto my branch just to make sure that I'm constantly getting the latest stuff from master. And then in doing so, I just make it easier on myself in the long run. So and we can do a quick rebase here. So if I've made a commit on feature, what I'm gonna do is I'm gonna check out master, and then I'm gonna make a new file here. I'll call it what do I call it? Touch em.txt. Just add a file here. Okay, so what I've done essentially now is on my master branch, I have 3 commits: initial, added name, and add file. If I check out my feature branch, I do git log. I also have 3 commits: initial, added name, and add a new file. This is different from add file. So what I want to do is I want to bring the changes from master branch into my feature branch. To do that, I can do git rebase master, and you can see what it'll do. First, rewinding ahead to replay your work on top of it. Applying, add a new file. So this is where it removes all the commits down to where the last common ancestor was between the 2 branches. And then what it does is it applies the work from master onto feature branch, which is easy. It does that, no problem. That's never an issue because it's just fast forwarding it. And then now it applies all the commits after that. So applying a new file is good to go. Mason Walters, thank you for the 20. Just want to say thanks for all the content, man. It has been super helpful. That's really great. I'm glad to hear that. You should let me know what content you like the most. If you have any questions in the stream, please go ahead and ask them. I'll make sure I get those answered for you. But I'm glad the content's helping you. That's super good. And thanks a lot for the 20. If you don't have the supporter role, let one of my team members know on Discord, and they'll get you that role. Donish Cushing, engineer man, professor of the internet for the people. So much clean, correct content per video. Thank you. Yeah, I try. I really do. I try really hard to make sure that I make quality, clear content, and that it's easy to understand for everybody, and that people get some value out of it. Bank Birdsome, long time stream and long time supporter. Thanks so much for that. I haven't seen you in a while, although we haven't done a stream in a while, but happy to have you here. Thanks for all that. I appreciate that all. Yeah, the video can be watched on demand later. Absolutely. All the streams are always uploaded to YouTube, and you can always watch them at another time. Cool. Thanks so much for that. And again, if anybody doesn't have the supporter role and you've made a donation today, make sure you let one of my team members know on Discord, and they will hook you up. Okay, moving on. This is a good question. Unknown person asks this: how do you manage branches effectively? So I'm assuming, I'm making some assumptions on what he meant. I'm assuming he means like how to keep track of branches. And for sole developers, typically what I'll do is I'll just name my branches very explicitly on what I'm working on. So if I want to add a new feature that's related to, say, credit card processing, I'll call that branch updated credit card processing or something like that. But that's for sole developers. And typically if you're a sole developer, you're not doing a ton of work. You're only doing one man's worth of work. So it should be pretty easy to control yourself. There shouldn't be too much of a problem. It's really for teams is where it gets kind of tricky. So for teams, I always advise using some sort of tool. And what you want to do is find a tool that will let you kind of track issues. And it doesn't have to be some crazy, you don't have to, you don't have to go use Jira or anything. You don't have to get out the combine harvester to tidy up the flower pot or anything, but, find a simple tool that will map requirement to a serial number, like 1, 2, 3, 4, 5, 6, 7, 8. And then typically what I have people do is I'll have them make a branch. I'll have them prefix that branch with the number, and then I'll have them also put maybe like a word or two on what that actual thing is. So here again, your organization is probably going to have some, workflow already set in place for this, especially as it relates to like project management and keeping track of what's happening on the project. But in general, you should be able to control this simply with having a number and having the name of the branch. And then whoever is doing all the merging and reviewing, they should have an idea. Of course, Git's going to have all this data anyways. When somebody opens up a pull request, something like that, it's going to say what branch it originated on, and then you're going to see it right there. It's going to say where it's going to go into. It's going to also show you the changes and the commit messages. So you'll have a pretty good idea on what it is at that time anyways. This is just kind of extra just to help keep track of it. But that's how I would manage branches effectively. This is another good one. Unknown person asked this. How do you decide to move code to a new repository or simply keep it in a separate project in the same repository? This is a fantastic question because I've worked with a lot of organizations that argue about this as to should it be one giant project? Should it be a project per component? And the general answer is sometimes it's obvious. Obviously you wouldn't store your Android code in your iOS project. You wouldn't store your iOS project in your web project, and you wouldn't store your web project in your Android project. If it really is that easy, then that's all there is to it. However, when the code starts to become related, perhaps you have a complicated web front end and you have a complicated web back end, and you're wondering, should this be in the same project? There's a couple things I typically look at. The first is going to be, how is this thing deployed? Who's going to work on it? Are there any access and restrictions that I want to make? And then how is the project organized by, both from like a project management standpoint as well as people. So, if this is a project, like if you have a web project that's going to be deployed to a web service, but then you have a front end project that's maybe deployed in another way, then it may make sense to actually split that into two repos. If you have two independent teams that maybe work in two separate geographic areas, sometimes it makes sense to maybe use a separate repo for each, as long as the projects are significantly different. Of course, if you have people working in two different places, but they're working on the same stuff, then that's not a good reason to do a different repo. But if you have completely separate teams that work on completely separate things, then you may want to use a different repo, and you'll get a lot of benefits from that. The first and most obvious benefit you're going to get is that people's work will never step on the toes of other people's work. If you have a repository with a lot of code velocity, then you're constantly having new things added, and it's going to slow people down, having to do merges and whatnot, even if they're unrelated. So, and then of course, if you want to restrict access to a certain people for a certain project, then it makes sense to just make a repo for stuff that is specific to one group of people. So unfortunately, this question, it's a fantastic question, but there's no clear and cut answer other than just try to group your code into logical groups of related stuff and who's going to work on it. It's typically what I do. I prefer, generally speaking, I prefer a larger repo to many small repos, just because I find it's less maintenance. Obviously, one repo is easier than two repos. So why Git over SVN and Mercurial? An unknown person asked this. We talked a little bit about SVN earlier, and so the answer to why Git over SVN is that Git is distributed and SVN is not. That's a clear cut reason on why you'd want to choose Git. Over Mercurial, that's a little more complicated. I find that it's mostly based on preference in general. So Mercurial is another distributed source control system. I never used SVN or CVS or anything like that. The very first organization that I worked with was using Mercurial. So Mercurial is actually the very first source control system that I ever used in my career. And it worked fine for me. Honestly, that was 7 years ago, 8 maybe. And it worked fine for me. I moved to Git because, well, I didn't even realize Git existed at the time. I didn't realize Mercurial existed at the time. So I like Git just because everybody's using it. And also, of course, Linus Torvalds made Git. He's the same guy that made Linux. I really like Linux, ergo I'd probably really like Git. And that's what a lot of people were using, so I decided to move to that. But is there a benefit to one over the other? Yeah, there's probably a couple small things, but in general, everything Git can do, Mercurial can probably do, and vice versa. They're not that different. They are distributed. They're both distributed. That's the most important thing. So it's like all distributed source control systems are better than non-distributed. And therefore, the difference between Git and Mercurial is largely preference and whatever you kind of want. Okay, next one is, what is the point of origin? And so with Git, you have these things called remotes. And you can have lots of remotes. However, the default one is called origin. And origin represents basically the place you cloned it from. So if you do a git clone on, say, engineerman/YouTube, then your origin is going to be engineerman/YouTube. And then that's where, if you were to make a change to that repo and do a push, it's going to push it to engineerman/YouTube. So simply, the point of origin is just wherever you cloned it from. However, you can change this later. Just because you cloned a repo from one spot does not mean that you can't change its remote. So if, like recently I was working on a project, we were working on it on GitHub and we changed to GitLab. And after we changed to GitLab, I simply pointed the origin over to GitLab and that was that. So you don't have to reclone it or anything like that. Yep, Ubuntu, Ed, or Adam. Cool. Opinion on GitHub CLI. I wanted to include this just to say that I got your question. Unfortunately I haven't checked it out yet, so I don't know anything about GitHub CLI just yet. Next question is from Yost. Hopefully he's on here. And this is a great question. What should you use branches for? And I should probably answer this first, but I wanted to answer them in order just in case I didn't get to some. So what branches are for is, branches are great for several cases, including branches are great if you want to experiment with changes that you might just chuck and get rid of. Because you can create a branch, you can do some work, you can try some stuff out, and then if you don't like it, you simply discard the branch, and that's it. It's like the work never happened. The main branch on your project is just as it's always been, and everything's good to go. So that's one good use for it. Another thing is if you need to work on multiple things at the same time. The thing with branches is that imagine this case. Imagine you're on master branch, you're not using branches, and you're working on a new feature. You're typing, you're doing work, things like that. And then somebody says, oh my God, we have an emergency in our code base. We need to fix this bug ASAP. And then they say, Brian, fix the bug. And I say, well, I can't fix the bug. I have all this work I'm working on. Well, we don't care, fix the bug. So what do? Do you just commit your work half done and fix the bug? Well, no, because now you're going to deploy the fix for the bug. And it's also going to drag up all these changes that you're not done with. And that's the real power of branches, is branches let you work on things independent from your main branch. So imagine that same scenario, but in this case, I've used a branch. So I've checked out a feature, I'm working on my stuff, new cool feature I'm making, and then somebody says, oh no, we have a bug in production, we gotta fix this ASAP. All I do in that case is I commit my work to my feature branch, I check out master branch, I fix the bug, I make a commit on master, I deploy it to production, and then I switch back to my feature branch, and I start working on my stuff again. Easy peasy. And that's the big benefit of branches. Branches is also good if you want to isolate code for whatever reason. Maybe you want to do it for review, or you just want to share it with a team member who wants to check it out, what you're doing, or use it as an example. You can push that branch up, and then people can have a look at that. And it's a great way of sharing code without affecting the master branch. You want to try to, like we talked about earlier with Git flow, you always want to aim to keep the master branch clean. You want to make sure that code that goes into the master branch is stuff that's ready to rock, ready to go to production. There's no problems with it, and that's it. But it's also for these things we call hot fixes. Hot fixes are when something happens in production and it's an emergency fix. You go straight from master branch, make the fix, commit on master, and then away you go. You don't bother with a feature branch in that case. There's no time, there's no point. Because you're going to merge it to master anyways. There's no testing process. You're just trying to get it fixed ASAP. Our next question is from Hawkerino. It was, how do you effectively program with others using Git? And this is basically what I'm describing here is Git flow. Start by protecting master branch and limit who can merge to it. And then for those that can't merge directly to master, create a process for how they will. And oftentimes that process is a thing called a pull request. And a pull request is nothing more than a request from somebody to say, I would like to merge my stuff from my feature branch. I'd like to have that merge into the master branch. And oftentimes the person who will be doing that merging is somebody senior on the team who knows the project and who will merge it in when it's ready. I like to take there's like if you look at the Linux kernel, for instance, that has what's called a benevolent dictator for life. And that's, of course, Linus Torvalds. He has the single and sole say on anything that gets merged into the kernel. Nobody else can override that. Maybe his lieutenants can, I don't know. But in the typical flow, he's the gatekeeper. He's the final filter to anything that might get into the kernel. And so he's the one who's actually doing that merge. Everybody else is just prepping code that should go into the kernel. And then somebody has to have that role, and I think it's a good one. I think it works well. And it should be the guy with the most amount of experience on the project. This was actually a good question. This was asked by Grant. He said, can I version control my home directory, and what problems could I run into? I thought that was an interesting concept, and it's certainly possible. I've heard of people doing this, but there are definitely some challenges, and these are the ones that I thought of. If you want to version control your home directory, of course you can. Go in there, git init in your home directory, and git add and git commit, and then you'll have now a huge repo. Of course, you gotta have somewhere to put it. So a couple of problems I could think with that is you might commit your security sensitive stuff like your SSH keys or various configuration that's stored in your home directory that's either stored out in the open or whatever. You may unknowingly commit that. Of course, you could ignore those files, but you'd have to do that up front and make sure you get it. The thing with Git is that when you commit something, you really have committed it. Like if you commit something with Git and then you remove it and commit the removal, it's not gone forever. Somebody can always revert back to the point where you committed it and then see those files. Excuse me. So it's not like if you remove something from Git that magically it's gone. The only way you can remove something permanently from Git is to actually change the history such that it was never there to begin with. And even then, there's some cache area where you can still gain access to those commits sometimes. So it's tricky. You got to be careful. When you commit stuff, you really have committed it. So another problem is if your home directory is 300 gig, of course your repo is going to be 300 gig as well, or pretty close to it. And then if you're using a service like GitHub or Bitbucket or GitLab, like the hosted GitLab, not the one that you run yourself, sometimes there's file size caps, repo size caps, and you may run into that depending on how large your home directory is. If you're running your own on-premise version of GitLab, you shouldn't run into that problem. You should be able to have a repo that is as big as you want. It could be as big as the size of your hard drive, for instance. And then, another problem with Git, with doing this is binary files cannot be diffed. So Like usually when Git does merges, it does it on a line by line basis, but that only applies for text files. It doesn't try to diff and merge binary files. Binary files are just binary files. So if you add an updated binary file, it's simply going to just take that on top of the existing one, and that's the end of that. You're not going to actually have a diff between the two. So that could be a problem. If you have a 100 gigabyte binary file and you make just a small change to it, you're going to get a 100 gigabyte new commit. You're not going to get just the difference between the binary files. Next question was asked by Calix, and this is a good one. Merging and stashing, what the heck does that mean? So the big thing here is the stashing. Stashing is something that I'm going to actually do an example of this. So merging, of course, we've talked about that. Merging is simple. It's taking the contents of one branch and add it to another branch. That's what merging is. So it takes your commits from one branch, puts on the other. Done by either a fast forward or a merge commit, just depending on, you know, what commits are on each branch. So, but stashing is a really cool thing, and I wish people use stashes more, but a lot of people don't even realize it exists. So stashing is a terrific tool. Stashing is, let me make a change here. All right, so I'm gonna create a new file. I'm actually just gonna git reset a couple things. So I'll git reset soft. Okay, got two files here. So I have a git log. So stashing is nice if, what stashing will do is it'll take my current changes and it will temporarily commit them to this area that's not actually in the repo. So you can see your stash by doing git stash list. You can see that mine has nothing in it. If I run git stash, what it's going to do is it's going to take all my changes, so em.text and number.text, and it's going to add them to my stash. If I do git status now, you can see that it's like my files are gone now. You know, I have a clean working directory. However, if I do git stash list, then I have stash 0, work in progress on feature, whatever, added name, and 2 to name text again, whatever. So I have this stash entry here, and then what this allows me to do is do some work on this branch, and I can reapply the stash later. I like to use stashes when I want to. A great use for stashes is if somebody makes updates to a base branch like master, and then you have work on your feature branch that is not yet committed. What you can do is you can stash it, you can fast forward your current branch from master, and then you can apply your stash back onto your branch. So what I've done is I've pushed changes to my stash. If I want to pull the changes back off my stash, I can either do git stash apply, which will just take the latest stash entry and apply it to my directory, or I can do git stash pop. And what git stash pop will do is it will apply the latest stash entry and then remove that stash entry. So I do git stash pop. It applies both those files back into my tree, and of course now my stash is empty and my directory looks like it did before I stashed. So think of it like a temporary committal area. Oh yeah, Arir said only if you aren't modifying the same file. That's absolutely correct. So if I stash em.text and then I pull in a change from master branch which contains a different version of em-text, then what will happen is when I do git stash pop, it will actually have a merge conflict, which is fine. You just resolve it. It's no big deal. Typically merge conflicts from stashed items are generally not that big, just because you're usually not stashing thousands of lines of code. You're stashing just a little bit. So, but you're absolutely right. Thank you for that. 100%, you could possibly have a merge conflict on that, although it would have to be the same file that's being edited. Absolutely correct. It's also useful when you're working on the wrong branch. Yes, it's absolutely correct. So typically if you're working on the wrong branch, you can actually just switch to the other branch. It'll just move your commits over, unless the file that you've modified is different from the one on the other one, then it won't work. But yeah, If you're on the wrong branch, git stash, git checkout, git stash pop, good to go. So the stash is sweet. I use the stash all the time. The next one is asked by WH Brown. What's your workflow for merging many commits from feature branches into the main development master branch? And how about squashing versus rebasing? What are the reasons for using one or the other? So if I want a clean history, I'll squash commits. And that's because I want to, instead of representing the Git history as just a list of related or unrelated commits, I can have a Git history of actual useful things that were committed, and I can do so by squashing commits. And squashing commits is nothing more than taking, say, 3 commits worth of changes and just make them one, and then have a message that represents all 3 of them. That's essentially what squashing commits are. If I don't care about my Git history, I'll just merge it, and I'm not going to think twice about it. You know, on unshared feature branches, I like to rebase prior to merge, and that makes it easier to merge, and it typically has a cleaner history. Because if you, that's something else I didn't mention. If you rebase prior to merging, then you don't end up with a merge commit. Completely forgot about that. That's very important, because all you're doing at that point is you're fast forwarding it. You know, everything that's on the master branch is already on your feature branch, and therefore you get this nice clean merge that doesn't involve any actual merging. It just involves applying the commits from your feature branch onto master branch. No problem. Saki asks, how do you organize workflow in a local Git repo with multiple remotes? So Git, this is actually kind of a cool feature with Git is, you know, you have origin by default, and you get the origin remote just by simply cloning a repo. But a lot of people will have, you know, like mirrors. So if you mirror your code to another place, you can set up another remote, and instead of push, you can do push all. And that will, by default, git push pushes it to origin, and git all will push to all the remotes. So that's great if you have mirrors. For forks, adding another remote is actually a really handy way of pulling down changes from the original repo. So like if you find a project you like on GitHub and then you fork that repo, and you pull your repo down to your machine, what you can do is you could set up a remote on the original repo prior to you forking, and then if they make updates, you can pull that back down into yours. And it makes it really easy to keep your fork in sync with the main repo. So that's typically what I would do. Those are the only 2 use cases I know. If there's other use cases for that, and I'm sure there are, it's nothing that I've ever done necessarily. And then the final question from the Google Forms was from Ayush. I don't know if that's the right pronunciation. I apologize if it's not. Does Git create copies of the project at different commits? So when we roll back to the previous version, it simply uses that copy. So it doesn't copy it per se. What it does is Git is nothing more than changes to files over time. So every time you make a new commit, what you're really committing is you're committing the changes to a given file. And what this allows you to do is this allows you to roll back to any point in your commit history and see the project at the state it was at that exact time. And it does so by simply unrolling all the commits back to that point, or possibly reapplying it from nothing. But in any case, you can roll back a repo temporarily. You know, like you could discard the last 50 commits and see what it looked like at that point, and then just reapply them with git pull, or you can simply just check out a commit hash to just see what it was at that time. There's a lot of different things you can do, but that's one of the primary powers of Git. Is imagine how nice it is to be able to see your project at any point in the last, if say you have a 7-year-old project with 20,000 commits, imagine being able to roll back to a point 4 years, 3 months, and 12 days ago. You know, it's a fantastic power, you know, to have. It's my birthday. Thanks for the live. Well, happy birthday. Okay, let me just look at any more questions I missed. There's a lot of them. Okay, let's go in order. I'm gonna try to do this in like 6 minutes. We're coming towards the end here. Is Git safe? Yes, absolutely. As long as you're not committing sensitive things, which some people do. A lot of people think that if you commit a sensitive thing and then you say oops, and then you remove the sensitive thing, and then you commit that you somehow removed it but you haven't. So I guess in general it's safe, but if you don't know how it works, you can make a couple pretty bad errors. How would you automate a Git process? Well, that's a good question. How would you automate the Git process? So I actually have a couple aliases. You know, like I have a Git alias which is done for the specific purpose of pushing my development branch, checking out master, merging development to master, pushing master, checking out develop. I use that all the time. I call it Git auto. It's just something I named, but I use that all the time when I want to do merges from develop to master. I just don't want to type everything out. So that's a good way to automate at least that process. So usually what I do is I look at, you know, am I running commands over and over, you know, that I can just put into a script? And if so, I will just do that. I'll make an alias for it and I'll make it easy on myself. So you just got to look at what oh, thanks for wishing me happy birthday. No problem at all, buddy. Happy birthday. So you stream every week or something else? It's probably going to be every 2 to 3 weeks, I would say. It's going to be as new topics come up, and then I'll schedule it, and then we'll do the stream. Is there compression in Git? If yes, what type? It's actually a good question. I actually don't know. I don't know the exact algorithm. I do know that there is compression at a bunch of different stages. There's compression before it pushes to a remote. There's decompression when the remote receives the data. There's compression just in the repo itself. And then there's compression with, over time, Git will try to reclaim some of the size. They'll do so by way of a process called packing. And compression happens at that time as well. So there's definitely some compression used in Git that happens at various points while using Git. Let's see. Is there a known or recommended practice for a directory naming scheme? Not really. It's all based on your project. I mean, some projects, some frameworks, for instance, might dictate a certain directory naming scheme. So there's no set amount. Are there any uses for Git outside software development? That's actually a fantastic question, and the answer is yeah, absolutely. I mean, I could imagine. I saw something interesting on Twitter. It was somebody who suggested that we should use Git for like legislation. You know, imagine that. Like, okay, a bill was passed. We will commit to the repo, and then people can make changes to that bill, and they can have a feature branch for their changes, and they can be voted on. And then if the vote succeeds, they can merge into master. And in that way, you can see the changes to a bill at any point in time in the history. And you can do so with just a small repo instead of 5 million pages of documents. So yeah, I think there's tons of uses for Git. I actually use Git, like I played a video game called Astroneer. And what I did is I version controlled the game save file. That way, if I ever like made a mistake in the game and I wanted to just roll back to a certain point, I could just discard whatever I've done over the last hour or so, and then just load up the game as it was at a previous point. So that's kind of 2 use cases for Git that have nothing to do with software development. Let's see, something I can run. Is Git something that can be run with little effort on a local machine to track changes for solo dev work? Yeah, in fact, you can use Git without even having a remote. Like, just go into your directory and do git init, and then every time you make a change, just do git add, git commit, and that's it. You don't even have to push it anywhere. And then what that'll do is that'll give you almost like this undo queue, you know, whereby you're like, oops, I want to go back to what the file looked like, you know, an hour ago, and then you can just undo whatever and check it out. So yeah, if it's just solo dev work, you don't even have a GitHub or a Bitbucket, you could still benefit from Git just in that way. So the answer is absolutely. You can absolutely use it. Let's see, when you add tons of resources in the repo like tutorial videos and stuff, is the Gitignore meant to exclude those exclude those files so you're not uploading them. Also with API keys, environment variables, etc. Yeah, so Gitignore, the whole purpose of Gitignore is to say if the file matches something in the Gitignore, then simply just pretend like it's not even in your directory. And you could do this for a number of things. I like to Gitignore things that are environment specific. Environment variables, I like to Gitignore config files, I like to Gitignore log files and binary outputs, intermediate files, and just a litany of other things. The stuff I like to commit is code I write and not things that are generated. So like the node modules folder, you wouldn't want to commit that. You just simply npm install, when you need it. So in general, yeah, you want to commit your code, not commit all the extra fluff around the code. Is it possible to add existing bare repositories to GitLab? The answer is yes, but it's not very straightforward. It's not something I can describe right now, but it is something I had to do in the past. It is definitely possible. I'd recommend just Googling that, and there's some resources out there that can help you do that, but it's not a simple process. What's your favorite Git tool? My favorite Git tool is just Git itself. I do everything from the command line. Git itself is fine. I don't need anything else. Oh, how to configure the text editor for a git commit message. Yours is in Nano. I want to configure VS Code. So I believe, don't quote me on this, I believe when you do git commit, it calls whatever is in your editor. Let's see. Maybe not. Let's see. What does it call? Okay, I guess I don't know. I thought I called whatever was in your actually. Let me try something. So touch b.text, and then I will do editor equals vim git commit. Oh, whoops. Git add. Editor equals vim git commit m. Oh, that worked fine. Okay, so it's going to take whatever's in your editor environment variable. So if vim is your environment variable for editor, then that's the one it's going to open. Why it opens Nano automatically? That's actually a good question. I don't actually know, but you can do it that way. No problem. Why do you think SVN is still in use? I'm guessing just because people don't want to convert it to Git. Maybe there's this. It's the same reason like COBOL is still in use. People don't want to convert over. Although converting to Git, of course, is a lot easier than converting to, say, JavaScript from COBOL. So I mean, certainly its use is shrinking, but there's always going to be a group of people who just use SVN for whatever purpose. I mean, the one thing, if I'm playing, excuse me, if I'm playing devil's advocate, the one thing that SVN does have is really, really tight access control. So if you want to guarantee that no two people work on the same file ever, then you can use SVN and that'll be perfectly fine. But here again, what's the point? We got tools that intelligently merge things now. How much file can we upload to Git manually? Because I have 500 files, I'm not able to do it on a single run. I think it just depends where you're putting it. If you're uploading it to GitHub, it's going to be subject to the GitHub limits. If you're putting it to GitLab that you own, there shouldn't be a limit. You should be able to send up a 10 gigabyte file if you want. Let's see. What's the difference between rebase and a stash? What's the difference between rebase and a stash plus pull? There's actually none. If you rebase, you're still going to have to deal with conflicts. The reason the stash plus pull is useful is if you haven't actually committed yet. Certainly if you wanted to not do stash pull, you could just commit your changes and then do the rebase and then you'd be fine. But I guess it saves you an extra commit if you want to just hold on to your working tree and not actually commit it at that time. What Discord channel would you guys prefer to use to discuss Git questions? You can do other languages or programming chat. I think would be suitable for that. What's a Git mirror? Git mirror is nothing more than a place where your code goes that's just purely for read only. Nobody does any work on it. Doesn't accept pull requests. Doesn't accept any of that. Like a good example of a Git mirror, you know, the official Linux kernel is stored on, I think, the Linux, the kernel.org repo, but they also have a GitHub mirror, and it's at torvald/linux. But if you go there, it says this is a mirror only. You know, don't submit issues, don't open pull requests, don't commit, don't do anything, because it's totally and completely ignored, and it's just a mirror. So a mirror is used for a number of purposes. Ooh, Git hooks. Okay, that's the last thing we're going to cover. After Git hooks, then we'll end the stream. So Git hooks is another thing that's not done super often. If we go into our repo here, we can see that we have a .git folder. If we go into the Git folder and we go under hooks, we can see that we have a number of different things. Now these are just sample files. These are not actual hooks. So hooks are basically shell scripts that you can make that will run at a given point in Git. So like a pre-commit, you know, let's open that. What the pre-commit does is this is going to be a shell script. Okay, that's a lot longer than I thought. Let's go with less. So the pre-commit hook will run like right after you run git commit, but before it's actually committed. So I know we used to use this to do things like automatically add the issue number to the commit message. That way our system picked it up. So this is a way of like rewriting a commit message or running some other script. You know, hooks can be used to make HTTP calls when you push or when you commit. So there's a number of things you can do. And this is one of the ways that Git makes things very generic and allows you to, it's almost kind of like meta. This is meta stuff right here. And you're able to hook into a lot of different places: commit, post update, pre-commit, preparing commit, you know, rebase, push, update, and so on. So there's a lot of wonderful things. As far as I don't have any hooks that I use all the time. I've used them at organizations before, but for my own personal solo development, I don't use any hooks. There's a lot of, you could definitely Google for some of the hooks. There's going to be definitely some useful ones out there that you can check out. And I think that's it. I think we'll end the stream at this time. So if you want to go further on what we've talked about today, you should definitely join our Discord. I'll put the link in the chat right now. You can go there, check out our Discord. We got, I think, 7,500, something like that, 7,500 people. And there's a lot of stuff going on there, a lot of smart people, a lot of different topics and chats, things going on. I'm also there all the time. If you want to come say hi to me, certainly you can do so. If you donated today, and you have Discord, definitely let myself or one of my team members know that you donated, and we will get you hooked up. Get you hooked up with the donator role, or the supporter role rather. So this was a fantastic stream. This was chock full of content. It wasn't even enough to cover in an hour. We ended up missing a couple things. We got all the Google Forms ones, but we got so much questions. This was an excellent stream. So if you like this format and you like the interactivity and you liked all the Q&A and the demonstrations, then please expect that this is how it's going to be going forward for various topics, and we will carry out the streams in this exact same manner. So other than that, I hope everybody has a fantastic rest of their weekend. Be on the lookout for upcoming database videos and Linux videos, and in 1,800 subscribers, we're going to drop that 300K video. It is amazing. So it's going to be terrific. So yeah, have a fantastic rest of your weekend. Join us on Discord. And other than that, I will see you on the next video and or stream. Have a good day and take care.